Hello Algebra 1 students, and welcome to your first instructional video of the year that includes something you haven't learned yet. So this is literal equations, also known as what happened to all the numbers? So these are formulas and equations where you're going to be solving for a variable. This video is going to be new material. Have I mentioned that yet? Brand new. First thing that's not review. Let's get started. Okay, formulas or literal equations. So many problems in algebra require the use of a formula for their solution. And a formula is an equation that shows a relationship between one or more variables and some numbers, okay? So I really should say two or more, shouldn't it? Let's fix that. Two or more. Let's fix that, make it two. Anyway, let's look at real quick what these formulas are so we understand what we're getting at here. Let's, this is a triangle. A is the area of the triangle. And if this was my triangle, the H would be here and the B would be down there. So that's one. Another formula, another geometry formula specifically, the length and the width of a rectangle. And then P would be the perimeter. And then this last one is the basic equation for a line, where B is this value here, it's called the y-intercept, where m is something we call the slope, and then where finally the x's and the y's are ordered pairs that fit on the line. So here's some examples of formulas that we will use. Now, what exactly are we going to do with these formulas? Well, we're going to manipulate them. We're going to move the variables around so that it's still true, it still has the same meaning as it did before, but it's solved for a different variable than it is now. So let's start with a very simple yet very important formula. This is D equals RT, distance equals rate times time. So this is the formula that says, make a nice solid dot there so you can see it. This is the formula that says how far you travel depends on your speed and your time, and you multiply your speed times your time to get the distance you've traveled. And we want to solve here for t. So that means we have to get t by itself. So what I want you to think about is this right here, D equals RT. I'm going to write it again. It's kind of the same thing as saying 15 equals 3t. If the distance were 15 and the rate were 3, like 15 miles and 3 miles per hour. And what would I do to solve this equation over here, where I would divide by 3 on both sides? That would cancel the 3's on the right, and it would give me t equals 5. Now this is why we learn how to show the steps, because if you know this not by showing the steps, and if this doesn't make any sense, this is going to be a lot harder now. But this right here is a big reason why we learn how to show the steps, because we're going to do the same thing over here. We're going to divide off the part we don't want. Now we want t by itself, so we're going to divide off the r. It's the same thing as dividing off a 3 because it cancels. The difference is that in the end, you can't write the equation on, or the result here on this left-hand side, you can't write that as just one term, one number. It has to be a quotient. Instead of being a number, it has to be a quotient. So that means that the time is equal to the distance divided by the rate. And if you wanted to even use that symmetric property, you could flip that around to see that. Time is equal to distance divided by rate. So that's the basics of what we're doing here. Let's take a look at another one. Okay, so here's that one we talked about at the beginning, the top of the video here. This is y equals mx plus b. This is the line equation. Okay, for those of you who want to know this stuff, this is the line equation. You may remember this from last year. You may not. You may not have covered it, and that's okay. So again, I'm going to write it again. And I'm going to show you another analogy. So this time I'm going to write 14 equals 3x plus 2. And think of the x as still in the same position of the x, and the m and the b. So m would be this coefficient here, because it's the coefficient of x, and b would be this 2 over here. Let's think about what we would do to solve this over here. Well, we would subtract 2, giving us 12 equals 3x. Then we would divide by 3, giving us 4 equals x. Or if you think about it, 14 minus 2 over 3. Because that's what we did in order to get that 4 right there. Now, same idea over here with our equation. Instead of subtracting a 2, we have to subtract the b. So on the left-hand side, we're going to have y minus b, and that's okay. It looks weird, but it's the same thing as 14 minus 2. It's just that we have variables representing the numbers instead. Then I want to get the x alone, so I'm going to divide by m. So y minus b over m, and again, symmetric property, just to flip it around, is x. So we have solved the equation for x. We got x by itself. Okay, here's the other one that I had at the beginning of the video. We had perimeter equals 2L plus 2W. Now, I'm not going to give you another analogy equation because I think we've got it at this point. But what I am going to do with this one is point out that there are actually two different ways that I could write this one out. Two different ways and two slightly different answers. Okay, so let's put a wiggly down the middle. Let me write the equation again here so we can look at it from scratch. Okay, so on this first one, I'm going to subtract, I'm solving for L, subtract 2W from each side. And that's leaving me P minus 2W is equal to 2L. And then I want to divide by 2. Now notice, you cannot cancel these 2's right here. Please do not cross them out. This subtraction prevents us from doing so. So we're actually done because we have L equals P minus 2W all over 2. Now, that may not be what you would have gotten had you done this by yourself, because there's another way for me to think about this. Hold on one second here. Whoops. I always miss trying to get my handwriting bar thingy. See if I can get it this time. There we go. Okay, so P equals 2L plus 2W. The other thing I noticed for this one is I could divide off the 2, because these are both divisible by 2. So I could do that first, because that would get rid of both those 2's. So now I have P over 2 is equal to L plus W. And again, I'm still solving for L, so I'm going to subtract W from each side, leaving me P over 2 minus W is equal to L. Now let's look at how they compare, because they are equivalent. Okay, they are equivalent. P over 2 minus 1W. Now look, P over 2 minus 2 over 2W, or 2W over 2. So this is equal to W, and P over 2 is P over 2. So what's the key here is we have got to be able to recognize both as results that could come out of our algebraic manipulation, of our solving for the variable, because both of them are accurate. So I would have to be able to recognize both. Okay, just a couple more. All right, so this one, area equals 1/2 BH. That's our triangle formula. So A equals 1/2 BH. Now, sometimes we have to use those exceptions like we learned. So we're not going to add or subtract first. We're going, just like we actually did with the dividing by 2, so that second half of that previous example. Instead, what we're going to do is we're going to get rid of that 1/2 by multiplying. So now I have 2A equals, and 1/2 times 2 cancels because of the multiplicative inverse property. 2A equals BH. So again, I kind of forgot to mention this. Hopefully you're reading and paying attention. We're solving for H. Divide by B. So 2A over B is equal to H, or H equals 2A over B. I misspoke. Let me say it again. 2A over B is equal to H, or H equals 2A over B. Okay. Okay, last individual one, and then I'm going to put on a couple for you guys to practice and try out. Of course, I will put the answers in, so don't fret, don't get nervous. All right, so this one is another one where I'm going to have to think about how I can extract the variable I want. So I want the C by itself. So I want this C by itself. So I'm going to start off by multiplying both sides to get rid of the fraction. And I'm going to multiply by n. Now, it doesn't have to be this way, but traditionally, usually, you put multiplied variables in alphabetical order. I don't remember what this formula is. It doesn't really matter what it is. But at the moment, I'm going to put dn because that's alphabetical order and it's just sort of tradition. Oop, get the writing tool, not the pointer tool. All right, now C by itself, that means I need to add this S. So dn plus S is equal to C, or C equals d times n plus S. Now, if this were a formula I needed to use in, say, physics, and I knew the value of d, n, and s, then I could use this version to get C. Now that's going to be useful in future coursework. So next slide, we're going to have 4 problems. Let's take a look at them. Okay, so these are your 4 more problems, and I want you to try them. So I'm going to tell you what variables to solve for. In this first one, you're solving for P. In this second one, you are going to solve for the Y. Solve for Y. In this third one, you're also going to solve for Y. And then in the fourth one, we're going to solve, we're going to make this one sneaky. We're going to solve for R. We're going to solve for R on that one. So pause it and try it yourself. And my answers and work, or work and answers really in that order, are coming up in 3, 2, 1, answers. So let's run through these briefly. I'm going to change my pointer tool to one that actually points. So we have 1/3 times P equals N. So I multiplied both sides by 3, again, using my multiplicative inverse property. So time and time again, you'll see those properties pop up. That's the reason for knowing the property. Definitely makes that easier, because N divided by 1/3 would look very awkward and would be wrong because it's not simple. On this one, xy minus d equals m. We got rid of the d by adding. We got rid of the x by dividing. M plus d over x. Over here, y over 2 plus c is equal to d. We subtracted the c, got rid of that by subtracting. We multiplied by 2. Now notice I did not distribute. You don't really need to distribute these. This is actually a perfectly acceptable way to write it. Just make sure you do, again, recognize that. That's the same thing as 2d minus 2c. And then the last one was a toughie. We had to get rid of the 1/3 by multiplying, so I started there. Then what we have to recognize is that pi is not a number, but is not a variable, but a number. So well, actually, I guess it doesn't matter now, because that's the whole point of what we've been doing. We divided by pi. It's just like dividing by a number. So this is okay still, 3v over pi. And then we had to get the r by itself. Well, the only way to get an r by itself when it's r squared is to get rid of the squared, which we have to do by square rooting both sides. So that was most definitely a tough one on this last slide. So hopefully I didn't break your brain. Relax. We will do plenty of practice in the classroom. Do make sure you have good quality notes. Examples would be a good idea before you bring your notes for this one, because you will like having them when you practice this skill. All right. I will see you guys in class.